With both overlay analysis and suitability modeling, we're getting to some more complex types of analysis where you're getting just all sorts of different data coming at you. You're going to have to process that in different ways. And you're going to run multiple tools to ultimately get at your output. At this step, it's really important and can be crucial to start automating some parts of these analysis. Imagine that you're creating the suitability model and you're running it piece by piece of data, feeding into different tools, tool after tool for processing, ultimately to get your output. And then you realize you want to change one of those values that you put in a submodel. So again, if we're looking at earthquake faults and modeling hazard related to earthquake faults, let's say you did a buffer of 10 miles to an earthquake fault as being at the highest hazard. What if you did your modeling, did all these steps, and wanted to change that to 15? So if you just ran these steps independently, you'd pretty much have to redo a large chunk of that analysis, which is going to be a huge pain, and you also introduce significant error into making that change. So at this stage, it's really important to try to automate these processes so you can go back and change parts of the analysis without having to redo the whole thing. And the easiest way to do this in ArcGIS is with something called ModelBuilder. So ModelBuilder is Esri's graphical user interface for making custom tools through the design of a complete linked workflow. Basically, you're able in this ModelBuilder environment to drag and drop tools and data from Arc Catalog and to connect them together in ways that are saved for future analysis or for redoing the analysis. The result of creating a model within ModelBuilder is a new tool made up of many linked tools. You can save the new tool you built in ModelBuilder as a custom tool that you can then reuse. So in Catalog, a model exists as shown at right within one of these toolboxes. If you open up that model, you'll get this workspace where you can drag and drop these different elements that go into a model. So that's the ModelBuilder window, and this shows the very first steps upon the addition of the first tool to that ModelBuilder model. Before going in more depth into the different elements and definitions that are necessary for understanding how ModelBuilder works, it's important to once again revisit that idea of just kind of model in the general sense. Earlier in this lecture, and in a very early lecture, we talked about models kind of in different contexts, and now we add one more context. I just once again want to revisit that really general definition of what a model is. It's a simplified version of a concept, phenomenon, relationship, structure, system, or aspect of the real world. In this case, when we're talking about a ModelBuilder model, we're talking about the simplification of an entirely different thing than when we talked about data models or suitability models. Now when we talk about model, we're talking about a simplification of a workflow process. Instead of clicking through all these steps, we're modeling the entire workflow by linking together these different pieces of data and tools to show the entire workflow at once and to simplify that workflow. In addition to just simplifying the workflow, we're creating a visualization of a real-world process in a model form. So this is just once again to show the importance of being specific when talking about modeling in GIS. A lot of people say that they do a certain type of modeling or that they are involved with models in GIS. It's important to clarify whether they're doing suitability modeling of the habitat of some exotic bird in Latin America, or if they actually build geoprocessing models in ModelBuilder, or if they kind of work with different spatial data models. Getting back to the focus of this lecture, which is ModelBuilder itself, there's many reasons why you'd want to use a ModelBuilder model to simplify your workflow. The first thing that might be useful is that you're able to see a visual representation of analysis and geoprocessing steps. That allows you to kind of better understand the entire workflow of the processing that you're doing, and you can get a better look at the constituent subparts of an analysis. And this can just overall allow you to communicate what you're doing a lot better to other people. This kind of gets to the last point there, is this can enable you to share your geoprocessing workflows with other users. You can take a screenshot or export an image of an entire model, and someone looking at that model can understand a pretty complex set of processing steps and the data requirements needed to run a certain tool. You can save a lot of time on basic tasks just running them through ModelBuilder, especially when you start using iteration, which allows you to go through a list of files and do the same thing to all of them using ModelBuilder. So you can save a lot of time by automating your geoprocessing workflow. Related to this, you're also able to run a complex succession of processes as one tool. This allows you to simplify complex workflows that in the past you may have needed to kind of run one tool, then another tool, then another tool, and you'd have to like really remember the steps between them in order to not make an error. So things that you used to have to do more than once, now you can just do it once. It should work already if it's worked before in ModelBuilder, and you have to repeat fewer steps. Finally, you can plug in extra tools. There's the ability to easily integrate pre-made tools with custom scripts. You can kind of build on top of a model that somebody else has given you or that you've built to improve the capabilities of that model. Beyond those specific use cases, there are a few more abstract reasons why it makes sense to use ModelBuilder to kind of invest the time into building a model and then later running your data through it, rather than just doing it kind of the old-fashioned way and running one tool, then another tool, then another tool. First, it's easier. Once you automate, you don't have to remember the steps you took. You don't have to do them perfectly, exactly the same way every time. It's easy. You can just put in the input data and not have to worry about the intermediate steps along the way. Then it's faster. You don't have to point and click and wait for each tool to run. The computer works more efficiently than you. Right when one analysis step finishes, it automatically dives right into the other one. You don't have to enter more data or open more tools. All of that takes time. It just runs one tool, automatically acts on the output, and ultimately gives you a final output. Even if it's something that's really intensive to run, you can start your ModelBuilder model, not worry about it until it's done. You can go make a cup of coffee or take a bathroom break and come back. Finally, it's more accurate. There's a greater chance that you'll make an error during these intermediate processing steps than one of these automated methods would. This is especially true as workflows get more complex. If you're doing something like an elaborate suitability model with all these different pieces of data being processed in different ways and ultimately coming together at the end, it's really likely that if you do this many times every day with slightly different data or for a slightly different study area, you're going to make a mistake along the way. You might not notice it, but with a ModelBuilder model, you'll get the output you expect every time. If there's an error and you ultimately find it, it'll be corrected for all future iterations or model runs. All right, so with that basic introduction to why you might want to do ModelBuilder, let's look at like a really simple geoprocessing model in ModelBuilder. This one just takes two inputs, city limits and parks. Those are in those blue ovals. If you read the name of the output at the far right, you'll see that the end result will be a layer that shows areas near parks and within city limits. To get there, two tools are used, buffer and clip, in those yellow rectangles. When you put these things together, there's basically two different processing branches that come together in that last clip. With parks, we get parks input into the buffer tool to show which areas are near parks. Remember, buffer just kind of delineates space around a thing. Then city limits, along with that intermediate layer, are fed into a clip, resulting in areas identified around city parks, those buffers, being clipped by the city limits, giving you a final layer showing just areas that are near parks and within city limits. Things can get more complicated pretty quickly. This is still a relatively simple model in ModelBuilder, but it's quite a bit more advanced than that last model on the last slide. This shows potential bird habitat. That's not really shown in that oval that says final output, but if you look at all the data that's being input into this and all the tools that are being used, it is a type of suitability model where you're getting areas of good habitat. There's 5 data inputs. These are those variables that affect where's good for that bird. Each of them will have a submodel related to them, which include where for that variable is good for the bird versus where is bad for the bird. But those 5 inputs are vegetation, major roads, climate zones, slope, and elevation. Each of those is manipulated in some way according to the submodel that was designed for this model. And then ultimately, intersect creates an output for all those areas that are good that overlap. So you get a final output for values that are good for all these different things, and that's a place where it's more likely to find that potential bird habitat. So like with suitability modeling in general, the ModelBuilder workflow contains 5 steps. These are a little more applied and a little quicker than kind of the abstract steps of suitability modeling. You should have a good idea of what you want to do already when you go into building a model. So you should have a fairly specific workflow in mind. Maybe you already did this workflow outside of a ModelBuilder model and just want to automate it or implement it in ModelBuilder now. But the first thing you do is create an empty model shell. Then you add tools and set default parameters for all those things that you input. For those tools and data, you want to make sure that the data that you're inputting is correct and that the parameters for those tools are correct. And then ultimately you want to validate the model, make sure that everything's hooked up within the model the way you want it to be, and then run the model to actually see what output it gives you. As with suitability modeling, this can be an iterative process. You might not nail it the first time, but you can identify what went wrong. After you identify that something went wrong, you can go back into the model, correct where it went wrong in steps 3, and then carry out steps 4 and 5 once again. So now to kind of the nuts and bolts of ModelBuilder, there are 3 main elements in ModelBuilder. When you start a model, you'll start with a blank window, and you have to add these different elements that exist within these 3 categories. The categories are variables, tools, and connectors. And you're essentially always going to use all of these in a model, but maybe not all the subtypes of each of these 3 categories. Variables are data, or can also be constant values. So you can either input a data set as a feature class or a shapefile or a folder, or you can input a constant value depending on what tools you're running. Variables can either be input into a tool or they can also be output. If they're output, a lot of times they're intermediate values that'll just be fed into the next tool, or you can have a final output variable as well. So your final results of the model will be a variable. Then tools are often geoprocessing tools from a toolbox. These are usually things you will have already used at this point. Things like buffer, clip, overlay, all these specific tools that get data and output some other layer. Then connectors, usually you'll just use the data connectors, the top of these 4, although there are cases when you're going to want to use the other ones. These link the data to a tool, or the variables to tools, and then to variables once again. Environment, precondition, and feedback. Again, these are used for specific circumstances. Feedback connects output back to earlier processes. A precondition is something that must be done before other things can be done. There are definitely cases you want to use those, but we'll leave that for a future lecture. Then each of these model elements can have a state depending on if they're ready to run or not ready to run. That 4th step in the entire process was called validate the model. If it's not ready to run, it would not be validated, and each of these different elements would show up in gray. So a gray model is not ready to run. That means there's some problem with it. Maybe all the data that's required to run the tools that you've put into your model, maybe all that data isn't connected in the right way, or there's missing input data, so these tools can't be run. Otherwise, there could be some other problem with it. So in this case, the 300-foot school buffer actually needs more info. There's going to be a distance, which is distance from school, but we actually need information on where the schools are. You can't run a buffer around schools if you don't have an input that is where the schools are. Once it's ready to run, you get the characteristic colors for each of these different model elements. In this case, we were missing that thing that we want to find out an area around for, and in this case it's gas mains. So we feed gas mains and a certain distance around gas mains into the 300-foot school buffer to get a school's buffer. All right, here's another example of a pretty simple geoprocessing model that's ready to run. In this case, I'm going to demonstrate the output as well. I've talked through a couple of these already, but here we're actually going to look at what it results in. This is a model that searches for locations that are within 10 miles of major cities and 10 miles of major highways. We start with 3 different feature classes: US cities, US roads, and US boundaries. And we buffer each of these, so buffer the cities and buffer the roads. That gives us an output that's buffered cities and buffered roads. In this case, we're going to intersect them. That means we want to find places that are within the buffered roads dataset and within the buffered cities dataset, giving us intersected buffers. Ultimately, we clip by US boundaries because there's some places that maybe the areas that are within 10 miles of a US road and US city actually aren't in the US. We want to get rid of those areas. So we clip based on US boundaries to find suitable location, which are all those areas based on these 2 input data sets of roads and cities, areas within 10 miles of each. Let's see what that looks like. So here's an example of just major cities and major roads and those areas that are within 10 miles of each within the US. This looks like it's along the Highway 5 corridor in Washington State, kind of extending down to Portland. Now, this ModelBuilder model that you created is actually going to be available as a tool within the toolbox in Catalog. So you could run this again. You can run it just like a tool, but if you're looking back at what this model actually contained, you didn't really input any numbers here. You can hard code those 10-mile values into the buffer itself. And in this case, that's what was done. So there's nowhere to actually enter different values. So if you wanted to make it change your model so that it looked, 15 miles from a highway and 15 miles from a major city, you'd have to reopen this tool, click back into each of the buffer tools, and change that hard-coded value from 10 to 15. That isn't really a very practical workflow if you want to try a bunch of different combinations of values. So usually what you want to do is establish a model parameter. So as established looking at that model, this model is not flexible. It's kind of locked into 10-mile distances from roads, 10-mile distances from highways. It can't be used easily to establish other areas or distances from these things without going into the model and actually changing the model. So again, if you want to run this ModelBuilder model outside of that actual ModelBuilder model, where you're kind of like testing the model and you want to run it as a tool, you have to establish parameters. So establishing parameters within your model makes the model a lot more flexible to wider contexts. If you recall, when we kind of generally run tools in ArcGIS, all those different numbers and selections that you fill out when you're running a tool, those are parameters. Within a ModelBuilder model, you can actually set which of your inputs, which of those input variables are parameters. So in the case of the model we just looked at, if you want to be able to use it with other data within a tool, rather than changing the model itself, you can establish which inputs should be model parameters. So in that model, if we want to look at a larger area, we'd want to establish buffer distance for each of the inputs, so the roads and cities, as model parameters. So then it'll be like when you normally run a buffer tool, you're asked for distance. So to do this, you just have to go back into the model, and this time, instead of just like changing the buffer distance, just say, we want the buffer distance to be a parameter. Then in the future, instead of being hard-coded to these 10-mile buffers, you'll be asked when you run the tool, how big of a buffer do you want to look at, and how big of a buffer do you want to use? All right, so let's see what this would look like if, for that last example, we designate buffer distance and what data sets you're going to use as model parameters, instead of just having those be hard-coded to that really specific instance of US roads, US cities, and 10-mile buffers. So we return to the ModelBuilder window. In this case, we have these 4 input ovals now: cities buffer distance, roads buffer distance, but we've marked them as parameters. So this includes just right-clicking on that element, or those 4 variables, and selecting parameter. So now cities, city buffer, roads, road buffer, and also the total overall boundaries, which are like the US boundaries, kind of closer to the end of the model, are all designated as model parameters. And you'll input them as you do with normal ArcGIS tools, instead of them being hard-coded into the model. So when you launch the model, it'll look something like this. We still actually have 10 miles as linear distance for the default value. You can actually keep that as a default value, but you have the option to change it since it's now a parameter. You can also input your city's data set. So you can choose any group of cities you want. You can have a more detailed cities data set than what we had before. Similarly, you can change roads, you can change boundaries. So now that we've abstracted this model a little bit and asked for parameters, we can actually do this with all sorts of different data. If you had cities, roads, and boundaries for Canada, you could conduct the exact same analysis for Canada. If you had them for South Africa, you could do it for South Africa. So it really widens the scope of the type of analysis you could do. So here's another ModelBuilder model. This one you should be a little bit familiar with. This is what I described in the last video, that suitability model for matsutake mushrooms. Remember, the only input data set that I had there was the DEM of Gifford-Pinchot National Forest. All you have to do here is put a DEM at the beginning where GPDEM is, run the model, and it'll conduct all those steps just using any DEM for anywhere. However, again, you might want to establish some of these things as parameters. In this case, the input DEM, I've made a parameter if you look at the top right, and when you run the tool, you can put in any input DEM, and it'll run through these steps to give you the matsutake mushroom areas for that area. However, in this case, I didn't put elevation and aspect as parameters. That means if you're going to a different location and you want to use different ranges of elevation, you're not able to easily do that within the tool window. You'd have to go back into the ModelBuilder model and change those values. But overall, this makes it so similar analysis to what I did for finding Matsutake mushrooms could be carried out in other areas. Then this is another ModelBuilder model I made in the past while I was a graduate student. This one's actually not a suitability model like a lot of the examples we've seen so far. This is a model that I created to save time and to save myself from having headaches, basically. So both of these tools are actually Python scripts that have been imported. One of them took many hours to run, the other took half an hour or so. By linking them together and running them as a model, the whole analysis could be done without me being there, which happened a lot quicker. Because before I'd kind of run it and I'd have to keep checking if that one that takes several hours would actually be done before I could run the next step. So once I put it into ModelBuilder, once that first step finished, the second step automatically started. So I could just press OK, go, and wait for a handful of hours, and I'd ultimately get the results. And this particular model run that I guess I took a screenshot of here took 27 hours, 21 minutes, and 45 seconds. So it would have been a pain if I was checking every hour, seeing if this first part of the process was done before running the second part of the process. All right, so you should see now ModelBuilder can be super useful. I know some people are already in the Python class or already have a knowledge of Python. You can do a lot of this stuff in Python as well, but there's a lower barrier to entry to do it in ModelBuilder. It's a lot easier to do it in ModelBuilder. I think it's a little bit easier to just kind of like throw it into ModelBuilder. It's easier to just, not make mistakes, not have to check your work as much. And it's really good for visually communicating your workflow as well. So while you can do a lot of this in Python, it's useful to be pretty proficient in ModelBuilder too. And for that reason, the next 3 labs really focus on using ModelBuilder and becoming really comfortable with ModelBuilder. Most of the examples in lab will be with doing suitability analysis, but that's not always the case. So with that, let's take a look just briefly at what this week's lab entails. So for this week, the lab is actually going to be an Esri training or an Esri web course, and it's called Building Geoprocessing Models Using ArcGIS Pro. This is a pretty good introduction to building one of these ModelBuilder models, and it's also a good introduction to an applied use case for suitability modeling more generally. I put the link here. Of course, you can't click it from the YouTube video you're watching right now. This link will be in the assignment in Canvas as well. And the main deliverables to just show that you've completed this assignment and to get full credit for it are to download and then later upload the completion certificate that can be found at the end once you complete the training. And it can also be found in My Learning activity in your Esri account. And yeah, so once you download that, I'd like you to upload it to Canvas. I also ask you in the assignment document, so keep an eye out for this, to take a screenshot of your final results as well so that I can see that you got to that final stage and actually created the maps as asked for, instead of just taking the quiz at the end and getting to that step. So I think it's a really good intro to ModelBuilder. It's also a good introduction if you haven't taken advantage of Esri and ArcGIS Pro's online training materials. It's a good way to get your feet wet with that. Because once you're no longer in these classes, there's always still going to be stuff to learn, and it's really useful to be able to go on and find one of these trainings, complete it, and be a little more proficient in some specific area of GIS that you weren't really familiar with before.